we will combine the confidence interval and hypothesis together. We learned the confidence interval from the chapter 7 and the hypothesis testing from chapter 8, right? It seems like those two are different, right? So tonight, we are trying to understand there is actually some connection between those two. So in other words, we are making the same goal from different angle. We are trying to solve the problem from the different angle. So that's the what we are trying to do here. So we are using the same example here, everybody. If you remember, we randomly select 36 students, right? We find out their average cost of college, $59.50. Given the population standard deviation is 659, right? So I'm going to ask two questions. Previously, we asked the hypothesis testing question, right? And then this time we are going to do similar, but we want to do the confidence interval question first. If you remember, confidence interval, that we have three formulas, right? We are using the formula here because what? Because sigma, because of population standard deviation, right? So based on the 95%, 90%, 99%, they are asking 95%. That means 1.96. We are plugging all the numbers into this formula. We find out the 95% of confidence for the average cost of college, right? So we plug all the numbers. We find out the range, lower limit, $5,734. Upper limit, $6,165. In other words, we are saying 95% of time, or you can say 95% of students, their average cost of college will be in this range. Everybody, that is our upper limit. That is our lower limit. This is our upper limit. So 95% of time, they are in this range. If you remember, one of the hypotheses is trying to compare, they are trying to claim the average cost of college is that like 5,700, right? We are trying to compare that number. Everybody, pay attention for the next 1 or 2 minutes. So from the confidence interval calculation, 95% of time, we know where are they, right? Let me draw some pictures here. So 95% of time, we know they are here. Is that right? 95% of time, they are here. In this range, right? 95% of time. So that's most of time, what we say, right? Now, intuitively, if I'm asking you, can we say the average cost of a college is 5,700? Yes or no? What's your answer intuitively, everybody? 95% of time is here, right? 95% of time is in this range. So in other words, it's 5% of time outside, right? So if I'm asking you, if I say the average cost of a college is 5,700, it seems like it's hard to believe, is that right? Because 95% of the time, they are in this range, right? So in that case, we can easily reject that statement. You see what I mean? So that's the hypothesis testing. If we want to test, for example, they say average cost of college is 5,700. You see that one here, right? Let me erase that. They say, the question number 2, do we have enough evidence to reject the claim that the average cost of college is 5,700, right? At alpha equal to 5%. So now we know we can easily answer that based on the confidence interval here. Everybody follow me? Right? 95% of the time we are here. We are not here. So if people say the average cost of college is 5,700, that's not right. We can reject that. Follow me? Okay, so you see how the confidence interval is going to play in the hypothesis testing. So in other words, you can use confidence interval to make a decision for the hypothesis testing, right? So previously, we learned those two parts, like kind of independent, right? Now we say, oh, they are actually talking about the same stuff. And if you don't believe that, right, let's do an official hypothesis testing, 5 steps. Let's do that by those 5 steps. Let's do that step by step to see if we are going to reject that claim. H0 mu is equal to 5700 or not, right? So if you are paying attention to the question here, question number 2, they say the average cost of a college is 5700. So by default, H1 is not equal to, if they don't say it's higher or lower, right? So that's H1. Now, step number 2, we write down what's the test statistics, right? Plug into the formula. Everybody, remember the same number we got last time, 2.28. Remember? Is that right? So 2.28. Last time we got 2.28, and then we did use the, what do we call, p-value method to continue to solve that, right? So this time, this example here, we are going to introduce using the other method, critical value method, to solve this. Remember, critical value method is more powerful. In other words, critical value method can solve for the z-value formula or t-value formula, both, okay? The question is, if you have to use the t formula in the problem, if you have to use the t formula, then most likely you have to use the critical value method to solve for that. So let me quickly write down this so you understand what I'm talking about here. Let me draw something, okay? So here's what I'm trying to, here is what I'm trying to do, trying to impose that here. Let's see. If you are given, everybody, sigma, you are using Z formula. Is that right? Z formula. And then based on the Z formula, previously we can use the p-value method. Everybody follow me? That's what we learned before, right? P-value method. It's not that easy for me to write down this. Bear with me. And then if we are given S, we mentioned that we have to use T formula. Is that right? T formula. And then we can use the critical value method. Critical, right? Okay. It's a little bit difficult for me to write down the whole sentence, the whole words here. Critical value method, right? That's what we learned before. Follow me? Now, what I'm talking about a moment ago is we can also do this way here. If you are using Z formula, you can also apply this critical value method to solve that, right? The trouble is you cannot go this way. You cannot go once you have the T formula, right? And then use that p-value method to continue. You cannot do that. Is that clear? That's very tricky here. I hope that's the tricky part. I would say in terms of the hypothesis testing, this is the most difficult part. So tonight, this example here, we are going to use z-value, which we got 2.28. You see, that's the same number we had before, right? And then now, we are not going to use the p-value. I mean, yes, you can use that, right? But then you have another choice, critical value. I want to use that to help you understand. Like in reality, you really have two choices. Any questions? Follow me? All right, so let's continue here. I'm going to erase these notes here. If you can write down this on your lecture notes, that will be helpful for you to later. Otherwise, you may have so many questions, so many formulas, is that right? You got confused. Which formula to use and which method to use, right? So you see that, you understand better. Okay, I'm going to erase that. Now, find out the critical value. Everybody, where do we find out the critical value? Is from a table, is that right? From table. Which table? Can you type your answer here on the message box? Which table we are trying to find out? Trying to use for this critical value. Can you type your answer here? How do we find out the critical value here? From which table? Everybody? Z table. I see a few people type Z table, right? But why is Z table, not a T table, right? Previously, in the other example, we have used a T table. But here, why is Z table? Because what? We are using Z formula. Okay, it's very important. Now, the Z table here, let me open that. So how do we use that 2-page Z table here to find out the critical value, right? So let's first check, is that two-tail here? So H1 is two-tail. That means we have two sides when we draw the bell-shaped form. Follow me? The bell-shaped form here, we have two sides, right? Now, we know alpha is what? 5%. Now, if it should be given, right? If it's not given, automatically, alpha is 5%. So in other words, 2.5% each, everybody. So what is Z1 here? What is Z2 here? Well, this number, we got to solve for minimum, 1.96 plus or minus. That's the same as what we previously called critical value. You see that one, right? We call that critical value. And then region, those two tails, we call critical region. They part in the middle, what do we call non-critical region. Follow me, right? Now, once we figure out the critical value, everybody, is that clear? Any questions? Now, let's continue here. Step number 4, make a decision. Now, we know the critical value is 1.96 plus or minus. We draw a critical vertical line here, vertical line here. Compare with the data. Where's the data tells us? 2.28. Data is coming from the formula, from the test. So 2.28 is further away from the center. What's the center? H0. So data is further away from H0. What are we going to say? Everybody? Reject. Reject what? HO. Because data is further away from the center. So we are going to reject HO. That's the step number 4. Number 5. Reject HO, that means what? Reject HO, that means HO is not right. Why do we care about HO? Because HO is a claim. Remember? Question? They say, do we have enough evidence to either support or reject that claim? So now we can say this claim is not right. We are going to reject this claim. We are going to reject this claim, say the average cost of college is not $5,700. Everybody? That's the same conclusion as what we made earlier using the confidence interval, right? 95% of the time, they are in this range, right? They are not here. So if we say the average cost of college is $5,700, that's not right. Everybody, let me change this question a little bit. Can we say the average cost of college is $5,710? The answer should be no, right? Because 57 and 10, that's what? That's outside of this confidence interval, right? So that's not right either. As long as the number is outside of this confidence interval, then we have to reject that. Is that clear? So that's for this part here. In terms of confidence interval and hypothesis testing, right? We are trying to make the same conclusion, right, from different angles. So that's the what we want to introduce here in terms of the confidence interval, the hypothesis testing. This is a very, very useful part, used a lot in the industry for that.